Okay, today we're starting with our unit 4, which is graphing linear inequalities. So we're going to look at graphing linear inequalities with two variables and the solution sets, and then a couple examples to start off this part 1. So the first thing that we need to identify is what type of boundary line we need. Now, boundary lines are just the line that's created with the linear function. Okay, so we're going to start by creating the linear function and then decide what type of line it is and then what side we shade on. So identifying what type of line it is, when the line, when the inequality has the equal to, so less than equal to or greater than and equal to, we're going to use a solid line. The solid line signifies that the points that land on the line are also work. Here, the less than or greater than without the equal to, these are either going to be dashed or dotted. Kind of like our discrete functions, any sort of gap that they create. This second part is we have to identify this which way we shade. So as long as we have it set up as y and then the inequality, we're going to use this idea to decide which side we're going to shade. So when we're using the less than equal to or just the less than symbol, we're going to shade down or below. And then when we have the greater than equal to or greater than symbol, we're going to shade up or above. So whenever we graph this, the whole point of this is to figure out, do we use a solid or dash line, and then which side do we shade? So here's our example. We have y is greater than negative 1/2 x plus 1. So here we have the line for it. It's dashed because it is the greater than symbol. And we would shade up because it is the greater than symbol. And so therefore, all the points that are in this shaded region should work. So when we look at the first point, negative 5, 1, negative 5, 1, that is not in the solution set. So no, that does not work. When we look at the point 4, 5, we go over 4, up 5. That's in the solution set, so this one works. When we look at the point 0, 1, it's on the line. And so for this problem, because it is strictly less than, not less than or equal to, because it is strictly, or I'm sorry, greater than, not greater than or equal to, this is not a solution. If you do this algebraically, you would plug in these xy values into your equation. So the equation is y is greater than negative 1/2 x plus 1. My y value is 1. My x value is 0. 0 times negative 1/2 is 0. So, and 0 plus 1 is 1. So the inequality is saying 1 is greater than 1, and that's not true. 1 is equal to 1. It is not greater than. That's why this does not work. That's why this line is dashed. So the easiest way to go about this, and I can't get Desmos to come up with this, but change this to an equal sign and graph it in Desmos. When you graph it in Desmos, you'll get a line that starts here at 5. It goes down 1 over 3, down 1 over 3. So once you have your points arranged, then we have to decide what type of line is it. Is it a dashed line or a solid line? So if I look up here, this is greater than, it's over here. It is either dotted or dashed. So I'm going to go ahead and make my dashes. And then I look here, it is greater than, so I shade above. The easiest way to determine that is put your pen or pencil on the line and just shade up. Shade positively. So if we look at this, the question is 0, 0 solution? Well, is the point 0, 0 in the inequality or in the shaded region? No, it's not a solution. Plus, I love that they use this as a point because that's the first point I always check. My inequality is y is greater than negative 1/3 x plus 5. If I type in 0, 0, that means my y value is 0. My x value is 0. I love using 0, 0 because anything times 0 is automatically 0. And so I'm left with 0 is greater than 5, which is not true. That's why this is not in the solution set. So we have shaded the right way because 0, 0 does not work. 5, 6. I go over 5, I go up 6. That is well within the shaded region, so that's a yes. In problem number 2, again, graph it in Desmos. Y equals 3x minus 2. When you graph it in Desmos, you have a y-intercept of negative 2. You have a slope of 3, so up 3 over 1, up 3 over 1, up 3 over 1. Now the question is this a solid line or a dashed line? This is the less than equal to symbol. The less than equal to symbol is in the solid lines. So I make this a solid line. The second part is, do I shade down or do I shade up? This is less than equal to, and less than equal to shades down. For some of us, it's hard to identify which way is up, which way is down with these. I put my pen on the line and I just draw a line going down. That way I know, especially when we get later on when we're graphing multiple ones, that will help me identify which way I'm supposed to be shading. Then it says, prove algebraically that 3, negative 4 is a solution. We know 3, negative 4 works. It's right here in the shaded region. But it says prove algebraically. And what that means is plug the value in like we have been with these. So I'm going to write this out. Y is less than equal to 3x minus 2. This is my x value. This is my y value. So I change my y value to negative 4 is less than 3. My x value becomes 3 minus 2. 3 times 3 is 9. 9 minus 2 is 7. Negative 4 is less than or equal to 7. Yes, that's true. Negative 4 is less than 7. It is not equal to, but it is definitely less than 7. So that's why that point works. If we look at problem number 3 is different. Problem number 3, if you type in x equals negative 2, you get a vertical line right here at negative 2. So the first question is this solid or dashed? This is the greater than symbol. So the greater than symbol is right here with dashed or dotted. So let me go ahead and make my dashes or dots or whatever you want to do. Anything that shows some sort of gap. Then the second question is, do I shade up or down? Now, here's the issue with this. This is x is greater than negative 2. There's no shading up. There's no shading down because that's where the line is. So with this, these symbols, whenever it is an x, we have to think left or right. So if I look at my x-axis, which way is less? Less is this way, more is this way. So this can also be left and right. So when I look at this, all my x values greater than negative 2. Well, where are all my x values that are greater than negative 2? Well, they're this way. So I'm going to shade this way. Those are all my x values that are greater than negative 2. I just went ahead and underlined them, and now I'm like, oh, wait, let me go ahead and underline the entire space because it's all of that. Is negative 2, 3 a solution? No, it's not because it's on the dotted line. Is 2, negative 2 a solution? Sure is. Problem number 4 brings back a little algebra, and we need to get y all by itself. So here's my suggestion when I'm looking at this. I see this. And seeing a negative in an inequality worries me. I also see that this side is 0. And I need to just get y all by itself. So because this is -5, and because this is all by itself, again, if I want to get this to slope-intercept form, I need the x's and the 10 away from the y. I'm going to move this. This is going to be x plus 10 is greater than or equal to positive 5y. Now I'm going to divide everything by 5. So this is 1 over 5x plus 2 is greater than or equal to y. I'm going to have to be careful because my symbol right now, this is not set up in slope-intercept form. It's backwards. So I'm going to have to be careful when it comes to shading. But this could at least allow me to graph it. If I type this in, y equals 1/5 x plus 2, I can at least graph it. That'll give me a picture of 2. And I would go up 1 over 5 or down 1 over 5. This is the greater than equal to symbol. So this is a solid line. Now I need to know, do I shade up or down? It's saying the line value is greater than y. So one thing that I could do here is I could test out some points in the original problem. It gives me the point 0.05. I'm actually going to skip that. I'm going to use the point 0.00. I'm going to go to 0.00, and 0.00 is going to tell me, should it be included or should it not be included? So I'm going to make this, I'm going to make my x value 0, my y value also 0, plus 10 is greater than or equal to 0. If this is true, then this point works. If this is not true, then this point doesn't work. I have to shade in the other direction. 0 minus 0 is just 0. All that goes away. I'm left with 10 is greater than or equal to 0. Is that true? Yes. So therefore, this point should work. So therefore, everything below the line works, which feels goofy because of this. But this is only true if it is in slope intercept form. This is not true slope intercept form because the y is on the wrong side. So let's look at these points. 0.5. Does 0.5 work? Based on our graphing, it should not work. So if x was 5, y was 0. Oh, my bad. I got that wrong. If x is 0, luckily I have a pen that has an eraser. If x was 0, y is 5 plus 10. Well, 5 times 5 is 25. Makes it negative. Negative 25 plus 10 is negative 15. Is that greater than or equal to 0? No. So that tells me that I shaded in the right direction because that point doesn't work. Does 0.2 work? 0.2 is right on the line. That should work because it's a solid line. That last one was a bit of a tricky one. We have to watch for things like that when our inequality is set up, but it's not set up in slope-intercept form. Then some of these rules might not be in place. But you can always test points to make sure that they work. All right, that's our first set of notes.